Today, we are going to expand upon Arduino multitasking from our last lesson where we looked at hardware and software interrupts. And today we are going to be expanding beyond that to look at a very powerful function, which is called the Millis function. Now, multitasking, or I should say seemingly multitasking with your Arduino, because the Arduino does read one line at a time going down your sketch. So it's works seemingly, simultaneously. But for the average viewer, if you're trying to interact with a project, it's good enough. It's actually pretty convincing, right? So with the Millis, you're probably at a point, if you're watching this, where you've already built a couple projects. You've gotten LEDs to blink, you have gotten servos to sweep, and you control it with the potentiometer. The problem is, have you ever tried to put the blink sketch and the servo sweep sketch together? It doesn't work so good, does it? Right? The light will blink and then it'll stop and then the servo will sweep and then it'll stop because it can only do one of these things at a time, because of the dreaded delay function. So we need the Arduino to multitask as best as it can. And so Millis will definitely open the door to far more complex projects. What is Millis to begin with, right? So your internal Arduino internally has a hardware clock, and this thing counts in milliseconds. The second you power up your Arduino or you upload your sketch, it starts counting. Whether you use it or not, up until now, you probably never used it. Or if you used it here and there, like the blink without delay sketch. So that's always there. So it's like, if it's counting anyways, we might as well tap into it, right? And use it for our projects. With Millis, how long can it count to? Is it like forever? You can just keep your board powered, all day long? Not necessarily. With the Millis function, it returns an unsigned long number. So that means you can keep going continuously for almost 50 days. Now, for most of our projects, that's pretty good. That's going to fulfill the needs for most of our projects. Now, if you are a scientist and perhaps you are collecting data over a 3-month period or 6-month period, well, you're going to have to do a couple workarounds. And there are workarounds for the Millis function. So the best way to kind of understand Millis is just to start using it, right? So enough talk. Let's start using the Millis function. So here we see that I have a freshie McFresh sketch here. And let's see what this Millis is all about. Can we see it? Let's see what it is. So in our setup, let's see if we can pull it up on our serial monitor. So we are going to serial.begin and we'll use ye old 9600 for our baud rate. Good enough, right? Okay. And for our loop, let's see here. And you can see that there's a whole bunch of things hooked up to my Arduino here. We'll get to that. We're not going to use any of it right this second. Let's just see what this serial monitor shows us. So we are going to serial.print line. Yeah, we'll put it like that. And what are we going to print? We are going to print the Millis function. And that's our Millis function right there, right? So that sounds pretty good to me. So let me upload this. Oh, and look at that. Look closely. My Arduino is not plugged in. I will be right back, people. Now we can officially upload this thing. All right, let's see what happens. And I don't want to save. Saving is for, people that are not confident. Famous last words, right, people? Always save and frequently. All right, so it looks like it uploaded. Let's pop open this serial monitor business here. Whoa. And you can already see the numbers going up and up and up. And this is counting in milliseconds. So looking at this, you can see that this number gets pretty big, pretty fast. All right. So if it can count up to 49 days, you can only imagine how big this number can get. And we're going to talk about unsigned long and exactly, what it is that means. But you can see, this thing is just churning and churning and churning. We're in the 30,000s right now. All right, that's getting a little ridiculous. Let's make that go away. A little ridiculous. All right, so we got a lot going on here with this circuit. So let's take a look at, maybe a simplified view of it. So with this circuit, you can see I have 4 things going on. Maybe 5 if you count the button. So we have a red LED, we have a blue LED, a green LED, a button, and a servo. So the objective today is to try and get all these components doing something different in a seemingly simultaneous manner. So let's see if we can do it. So let's start off with the easiest. Let's only look at that red LED and get it to blink without using delay at all. And then we'll tackle the rest. We'll just kind of build up from there. So we're gonna try and get that red LED to blink with no delays. Challenge accepted, people. Let's do it. You see me getting rid of all the serial stuff, which you know is a big no-no because like knowing me, we're probably gonna have to troubleshoot some of this code. Let's kind of start up here. And because we're dealing with different colored LEDs, I'm just going to set up the pins based on the color of the LED. So red pin, so we know that's our red LED pin. That I believe is connected to pin 11. We shall find out soon enough. All right, so we have our red pin. Anytime you're going to use Millis, you already know that you're going to have to set up a minimum of 3 variables, minimum. You're going to have to set up a variable that reads the current time, like what's the clock time right now? Is it 30,000 milliseconds? Is it 50,000 milliseconds? So that's going to have to keep track of the current time. And so of course that variable can just read Millis and be like, okay, Millis, where are we at? Where are we at? Right? So we're going to have to clock the current time. Then we are going to have to find the timestamp of when did this LED change states in time. Like say you're trying to blink your LED every 500 milliseconds. So when was the last time it blinked? Was it at the 500 millisecond mark? Because when it gets to the 1000 millisecond mark, it knows it needs to blink again. So not only do you need to know the current time, you need to know what time the thing happened, your event. It could be a sensor read, a blinking LED, whatever. So those are 2. And then third, you're going to have to specify a period. Like every X milliseconds, that's when you know to change the state. So say we want to blink our LED every 500 milliseconds. Well, that's, we're measuring blocks of 500 milliseconds. And we're going to have to know the current time and a past time that this happened to know if that 500 milliseconds has elapsed. All right. So, but we also need to be able to control the state of the LED. It needs to know, is the LED off? Because if it's off, well, turn on, and then vice versa. So let's get some of that easy stuff out of the way and let's get this LED state, right? And why don't we start with it off? Look, okay, so the LED is going to start off. All right, so now we need to come up with our current time variable. So let's do a unsigned long, right? And what is this unsigned long? Now, some of you may already be familiar with all this. We are definitely, I'm just going to create some space down here so I can write notes. So far, I imagine a lot of you have seen the int, the const int, which means a constant integer, an integer that does not change. You'll see oftentimes that pins sometimes are written this way because a pin is constant. It's not going to change, or you can just leave it as int. You have probably run across the byte. Perhaps you have run across the float. Maybe some of you have run across the long, right? So why do you normally see Millis used with unsigned long, So if you look at the byte, a byte can basically house, it's a container that can house anything from, I say, 0 to 255. Right? So 0 to 255 is way too small to use with Millis. Like you're going to fire up your Arduino, it's going to be done, So, okay, so byte's not a really good contender. We'll get rid of that. And we'll get rid of this constant right here because Millis is always changing, right? So float, it kind of has to be a decimal and like Millis counts in whole numbers. So that's not a really great candidate. All right. So that leaves us our int. And int is still too small. It just, it goes from negative to positive, but something like this, it only counts into the 30-ish thousands of milliseconds. You're going to not even get to a minute in your program. You can't even run your program for a minute. So probably not a great contender. Long can house anywhere from 2 billion-ish to positive 2 billion-ish. Yeah, billion-ish. It's a little over 2 billion. Now this is a contender. So that's quite a few days, it's 2 billion milliseconds. That's usable. But if you look at this negative situation right here, that's just wasted space. That's 2 billion just units that you can't even use because we're always counting up from 0. Millis is never going to be negative, right? So is there a way we can kind of make this work in our favor? And that's where the unsigned identifier comes into play, because unsigned can only be positive. So in essence, it takes this negative 2 billion and it puts it in the positive category, giving you something that is like 4 billion-ish. 4 billion-ish in a little over 4 billion units, so we're milliseconds in the Millis situation. So the unsigned long is really the best variable container or data type container to be messing around with when you're doing working with Millis. So that's why you see unsigned long pretty much exclusively used with Millis. All right, so back to setting up our variables. We need something that's going to measure our current time. We'll call it the current Millis. What is a current Millis value, right? And so this Millis, well, in the beginning of the sketch, let's set it to 0 because nothing's happened yet. The clock starts at 0. So let's set that to 0. That's always going to measure the current time. And like I said, now we need a variable that's going to measure what was the timestamp that the event happened, like change of state of the LED. So let's also call this unsigned long, because depending on how long you run this program, the last time something could have happened could have been like, 50,000, milliseconds was that timestamp. So pretty safe to do that. Now, because we're blinking an LED and we're going to build upon this circuit, I'm going to be a little bit descriptive with these. So the blink previous Millis, like what was the previous timestamp that this thing blinked? Now, the previous timestamp, I'm going to start it off at 0 because nothing's happened yet. So everything's starting off at 0. We're zeroing everything out. All right. So the third variable that I talked about was the period. What's the rate of blink that we want? So for this, we can be all textbook and call it, unsigned long. And we can say blink period. That's a good one. Blink period. And what did I say? Half a second. That sounds good. All right. And you can see that I changed this up a little bit. I put, constant, because the blink period will never change. We want this to blink every half a second. Now, in more complex sketches, maybe you want to change the rate of blink, so you would take away that const. Now, for a number like 500, an unsigned long, a little overkill, I admit. But what I have found doing math, depending on how complex your math is going to get with these timers, I like to kind of match up the different variable types. So that way the math is happening with kind of the same variable types. And we'll see how that works a little bit later on. It seems to be a little more reliable, get a lot less wonkiness, right? All right. So I think that's all we need for this. And let's do our setup here, our pin mode. So the pin mode is going to be, our red pin is going to be an output because we're going to be outputting that blink. Yo, yeah. All right. So the loop. So in the loop, the first thing that we're going to do always is what's the current time? Like what time is it right now? So we are going to grab our current Millis. And how are we going to get that current time? Well, we're going to look at the clock. What is Millis telling us? So whatever time it is right now is going to be passed to this variable. So we know what time it is. All right. Now let's start writing our blink sketch. Now, when you're getting into Millis, I am going to assume that you are trying to time more than one component, because if it's just one component, you don't need to use Millis, right? So if you're trying to time more than one component, I actually like to set up each component as its own function. It makes the loop a lot smaller. It's also easier just to find that component and just change the code in there in that function, and it automatically updates in the loop. So you will find sketches and it's 50-50. Some of the extra functions are at the top above the void setup, or sometimes it's at the bottom after the loop. I like to kind of go in order. So we kind of have our loop set up, and in a loop, you always want to check that timer. So let's write our own function here, and we'll call it blink LED. I know, real creative there, but heck, it's descriptive. So what do we want to happen in this void blink? So we'll start with an if. So if the current time, and this is where we're going to do a little bit of math, nothing too complicated. And if the current time, and we subtract the blink previous millis from that, if that is greater than or equal to the blink period, what happens? So basically what we're saying here, if the current time, say it's 0 milliseconds because we just started this thing, and minus the blink previous, which is also 0 milliseconds because, nothing's happened. Well, that is not greater than 500 milliseconds. So we want the LED to stay off. But say we get to a point where we check the current time and and we minus 0. Say the current time is 500 and we take away the previous millis, which here was 0. Well, that is equal to or greater than the blink period. So we want that thing to blink. So let's start writing kind of more if statements, All right. So if indeed our elapsed time is greater than 500 milliseconds, what do we want to happen? First thing off the bat, you typically want to timestamp that. Like we are at the 500 millisecond mark. This is when the LED changes. Take note of that and put that in the blink previous millis variable. All right, I need to come up with shorter names for this. This is crazy. All right, so the blink previous millis is going to equal the current millis. All right, so basically it's 500 milliseconds right now. So that 500, timestamp it in there. So this remembers the last time we blinked this thing was at 500. So when it gets to 1,000, it'll be like, oh yeah, timestamp the 1,000, and it'll go timestamping every 500 milliseconds. Now, if this is less than, like we haven't really reached the 500 mark, well, there's no sense in it like keeping a new timestamp and a new timestamp. We want to keep only the timestamp of when this thing blinks. So that's why it's in this if statement right here. All right, so we've timestamped when this action is now about to happen. So if the LED state happens to be low, like this thing is off, well, we want to turn it on. So we're going to change the LED state to high. Oh, yeah, we are. All right. And ooh, I'm putting in too many parentheses. All right. And, or else, we want to keep it off. So let's keep this LED state off. All right. And then here, if you notice, we haven't like digital written anything yet. So we are going to digital write the red pin by the LED state. And I'm just like looking around my microphone here. It's in my way. All right. So I think that's that. We also have to make sure we have the correct number of bracketries. So if I see here, my else is matched up. My if here is matched up. But this one doesn't have a buddy. So we have to give it a buddy. Let's give it a buddy. All right. And to help me kind of find all this stuff, I'll just kind of do that. All right. So we've written what we want the blink and how we want it to work. So how do we call this in our loop? Now, some of you have already done this. You're very familiar with this. Those of you that have not, created your own functions, added them, this is how you would do it, So we are just going to put our blink LED right in the loop. So all in all, the way this sketch works is we've set up all of our variables right here. And let's skip down to the void setup. We've set our pin as an output. And in the loop, the first thing you do always is, what time is it? What time is it? And store it in here. And then it's going to go to the blink function. And it's going to go like, oh, okay, it's up here. So before we start adding more components, I like to check component by component so we can already rule out that this works. So let's do our little upload and no saving. Oh, it's angry about something. So let's see here. Declared void. All right. Oh, and look, I made a mistake. You got to put the little parentheses. See, I was putting parentheses over here, you know, but not where they actually should have gone. All right, no saving. Oh, it's angry here again. All right, so let's see what is going on. So current time was not declared in this scope. So it could be that I spelled something wrong, which is usually, oh, current time, current millis. Sometimes I will write what I talk versus what I set above. So the current millis. And let's make sure that I didn't do that again. So no, that's good there. All right, let's try this again. Is it happy? All right, people. Yeah, you want to give it like beady eyes or you want to give it the side eye, then it gets scared. So look at that. Our red LED seems to be blinking like at half a second. But let's see if this really works. Why don't we change the blink period to a full second? Now, because this is a variable here, it'll automatically update. So let's see what like a second looks like. No saving. It's so slow. Yeah, let's make it more action-packed. Let's bring it back up to 500 milliseconds. All right. Awesome. All right, guys, we've done it. We've blinked an LED with no delays. We're going to build on this, and there's no way we can get all this stuff working if we're going to use delays, you know, at the same time. So with the blue, let's move on to this blue business. What do we want to do with that? So the other thing we can do with LEDs, and especially if you're making props, you want different lighting effects. And this applies to LED strips too. Once you master this Millis, you're going to be able to have different animations going. So say a prop gun or a small robot, you can have kind of a steady blinking, I'm on. You can have cool fading, you know, that's kind of like a different lighting effect. So why don't we make that blue one fade on and just fade on, turn off, fade up, turn off, right? While that red one is blinking. Oh yeah. So we have our red pin. Now let's do our blue pin. And I'm just going to keep our color theme going. And I believe that one is connected to pin number 10. And like I said, we are going to find out sooner or later. All right. So for the blue, we want to fade it up. So what variables are we going to need? Now, for every component you add, you can't just be reusing this stuff. Except the current Millis. Current time is current time. It's applicable to every single component you add. But if you're going to have each component doing something at a different rate, it needs its own timestamp and it's going to need its own period. So this is kind of like where things start to get a little bit long, and it's going to need its own state. And so what we've done here so far is create what's called a state machine. So it knows on, off, according to the time. So we're going to create another state machine for our fading. And so what is some variables we're going to need? Well, obviously, we're going to need brightness. You know, we're going to have a way to control the brightness of the LED. So we'll just call it brightness. And we're going to start it off at 0. We're going to start it off. And I'm using byte because remember, byte goes from 0 to 255, which is conveniently what the LED PWM pins use for the fading. Oh, which reminds me, if you're going to fade an LED, make sure it's connected to a PWM pin, which pin number 10 is. So, all right. That's very rare that I get it like that, you know? All right. So we're going to start with a brightness of 0, but how fast do we want to brighten this? Meaning by what increment? Do we want to increment it by 5 every time the time period is up? Or by 10, so it's more like a choppy fade up? Or do we want a smooth fade up? I think I want a smooth fade. So let's do a fade increment of 1, you know, so it just fades up by 1 every time. So, all right. So basically you can see that I have my state machine things grouped here. I have my pins grouped here. And then I start to kind of group these things together. And everyone groups in a different way. There's no right or wrong grouping, you know? So let's make a fade previous Millis. It's pretty long. And let's set that to 0, 2, because we're just getting started. And we also need a period, like how fast we want this thing to fade up. And we'll call it the fade period. And I kind of like maybe 10. Yeah, 10. So every 10 milliseconds, it's going to fade up by 1, all the way up to 255, and then it'll cycle back to 0 because we are using a byte for this. So we have, let's skip that. We don't really need to deal with that anymore. Let's go in the void setup here where we need to set up our pin mode. So let's set up the pin mode for our blue pin, and that's also going to be an output. And all right, so in the loop, we're going to have to create another one of these things, another function. So here is the blink one. So I'm going to kind of create some space here and create another one. So void fade LED, right? We did blink LED, fade LED. Don't forget the open and close parentheses. And let's get started. Now you're going to see that a lot of this code is pretty much the same because it's how it works. It's what time is it now? When was the last time something happened? Subtract them. Is it time for something to happen? And if it is, if statement it away to your heart's content, right? So that's basically how these things work. They get a little bit repetitive. All right, so it's the same thing if the current Millis, which is gotten right first thing in the loop function. So if the current Millis is less than now the fade previous Millis, because we're not blinking. The blinking, is a different function. The fade previous Millis. And if it is greater or equal to the fade period, which is 10 milliseconds, well, what do we want to happen? Okay, so in this case, we want our fade previous Millis. Remember, you want to timestamp that right away. Our fade previous Millis to equal these long variables. You want it to equal the current Millis. So you want to make sure that you have that timestamp that something is about to happen. So now, basically, if that happens, well, it's time to analog write. Let's start fading up because we have exceeded our 10 millisecond situation here. So we're going to analog write that blue pin by the brightness, right? And remember, the brightness to start out with is 0. So we basically start dark. And then from there, we're going to start to increase the brightness. So the brightness is going to be by the fade increment. Gotta remember like the variables that I use. So basically what happens here is if the current time minus the fade previous Millis, like the previous time something happened, if that exceeded our 10 millisecond period, well, we want to go ahead and record, okay, this is the time that something's going to happen. We're going to increment our fading. So then we want to analog write that blue pin by the brightness. After that happens, for the next go around, we want to increase that brightness by 1. So this is where we go brightness. We're going to go brightness plus the fade increment. Now, oh, don't forget your semicolon. If you've never seen that plus equal operator, I'm going to create some space down here. All it means, it's shorthand for basically brightness equals brightness plus fade increment. So those two lines are exactly the same. The plus equals is just like a shorthand, so you'll see me use that a lot throughout. So we can get rid of that. All right. Looks good, I think. I think we got it all. So let's check bracketry. That's always where it gets us. So here's this bracket and here's this bracket. Okay, so we can't forget to add it to our loop because then nothing will happen. So I think it was called fade LED. Like that. So let's see what happens when we upload this thing. It's uploading. Look at that, guys. Hey, it's fading up. Now, if you recall from past lessons where we're learning to fade LEDs, the cool fade part happens right in the beginning. Once that voltage, or that your duty cycle starts to increase, it's very difficult for the naked eye to tell and see it getting brighter and brighter and brighter. So a brightness of like 170 kind of looks like a brightness of 255. And that's why visually a fading LED kind of always looks like it hangs bright, but it's not. It's just the differences are so subtle that our eyes can't see it. But you can see that our red is blinking at a rate of half a second, independently of our blue LED, which is now fading up. And then once it reaches 255, it turns off. And so it's just this kind of thing. Now, I spy me a green LED. So what can we do with this green LED? All right, so I have an idea. There's a button right next to it, right? So we have a blinking red, a fading blue. Why don't we make the green like a, when I push the button, it goes on, type of situation. So let's do that. Yeah. So let's see, we're going to have a blink, a fade, and a toggle. All right, so let's go back up here and see. And that's why I like everything in order, because you remember to add all this stuff. So now we have to add a green pin. We'll call it green pin. And this is going to be number 9. I'm thinking it goes down like that. And then, we have a button too. So the button pin. And that is, I can't tell. I'm going to go look. All right, so the button is number 7. All right. Okay, our button pin is pin number 7 and our green pin. So now we need to create, again, some kind of state machine for our green LED. So in order to do that, let's do a toggle state. Like we have LED state, let's do a toggle state. So we're going to start that at low, toggle state low. All right, so we have our current Millis, everybody uses that, but we need some kind of situation for our button. So we'll call it button previous Millis. Yeah, why don't we make it longer just cause. All right, and that's also going to be set to 0 because when this starts, nothing's going to happen. All right, and we need a button period. Signer. Button period. And we want to read the button, let's just go like every 100 milliseconds. I don't know, we can try different things, but that sounds good to me. Now, it's going to also have its own function, but let's just skip that for now. I always like to make sure, I always forget to set up pin mode, and then I'm sitting there scratching my head why things aren't working. So for our green pin, it's going to be an output. And for our button, you see that there is no resistor at all. And that's because, let's see, button pin, we are using the internal pull-up resistor, input pull-up. So we'll do that. So remember, when the button goes low, it means that it has been pushed. It's like opposite day. All right, so we have our loop here, which we'll add it once we write it. So here we stopped off at fade LED. So let's kind of like create some space here and call this toggle LED. This is our toggle LED. And it's going to be very familiar to you, so if the current time, and write Millis and not time, is you subtract the button previous Millis from it, and if that has exceeded our 100 millisecond check, which is the button period. I think that's what I call it above. Let me take a quick look. Button period. Well, what happens? Well, we want to record that time. So we're going to say button previous Millis, snag that time from the current Millis. All right. So now if we're checking the button, if that digital read is of the button pin, if it is equal to low, which remember now, it means the button has been pressed, what do we want to happen? You see, I'm throwing semicolons everywhere. So we want to toggle state. We want to make that equal high, right? Just like we did for our LED. So we want our LED to be written high. Then, or I should say else, we are going to toggle state. All right. And then here, we actually have to write out to the LED. So we're going to digital write the green pin by the toggle state. This mic is totally in my way. All right. So I'm just going to do a quick bracket check. And that one goes with that. And that one goes with that. Okay, so we called this toggle LED. So I'm going to add that. All right, guys, we're going to have like a couple things going here. So it's pretty cool. All right, let's upload that. No saving. All right. Now, of course, it looks like nothing's happening because I have to go over there and press it. Let's press this thing. Yes. You can see how you can apply this to a sensor reading. You know, perhaps the sensor has to be read every 1,000 milliseconds. And at that time, perhaps you want to print to an LCD screen that says, hey, it's this temperature or this pressure or whatever, you know, scientific thing that you're doing. Or perhaps it's something like an interactive robot where it's reading a touch sensor, where if somebody touches it on the shoulder, it behaves in a certain way, or on its head, you know, like a lot of the interactive fur baby style toys that we see. So I spy a lonely servo there. It's time to put him in action. So let's add to this a servo, and then we're going to have like a whole bunch of things going on. But you can see, you can kind of get the pattern of what's going on here, you know? So we're going to try and get the servo working, and you can pretty much copy this and add a ton of stuff, as much as you want, well, until you run out of memory, you know. All right, so let's add the servo. And the first thing we have to do when adding a servo is add the library. So you can either type it out, or we can just include the library here if you kind of like forget what the syntax is. All right, so we have our library. And now it's time to set up pins and all that kind of fun stuff. So now we got buttons. Really, the only pin we're worried about here is the servo pin. And I forget what the servo pin's connected to. I think it's 6. Yes, because if the button is 7, then the servo is 6. I think I put everything in a row. All right, so let's create what kind of state machines do we need for our servo. So we definitely need some kind of increment to move that arm. So let's call it servo increment. You know, I guess since we have fade increment, we can have servo increment. And we're going to start this thing at 0. And let's do, I guess, an initial servo position. We're going to start that at 0 too. So actually, we want it to increment by 1 every round. If it increments by 0, it's just going to sit there. So that gives us a more smooth move. Although with these little micro servers, they're kind of jerky. But if you have like a nicer quality servo, you know, a 1 degree per round is going to be nice. You know, or you can do 10 or 20. Whatever it is you want until 180. So I think that's that. And we have our, well, before we get too far, let me create my servo object. So let's do servo. I'll just call it servo because we only have the one servo. So we'll just, you know, keep it at that. And now we can create these things for it. So unsigned long servo previous Millis. And we're going to set that to 0, just like everything else. And now we need a servo period. Servo period. And how smooth? We could do 15 milliseconds. That's kind of like a nice, smooth, fast enough, you know, type of sweep. I think that's pretty good. All right. And now I'm going to jump down to the setup. Let's just kind of get that resolved so I don't forget. And we have well, we don't necessarily have like pin modes, but we do have to attach the servo. That's it. So servo.attach, and it's attached to the servo pin. All right, so I think that's all we have to do for setup. We're going to come back to this loop because now we have to write one of these for our servo. So we'll call it servo sweep. All right. We'll squish it together. All right. And I'm going to just move this up so we're not like watching the screen like this and we get like achy neck. All right. So as you may have guessed, we are going to do the current time to the last time something happened comparison. So if the current Millis minus the servo previous Millis, and if that is greater than or equal to our servo period, I'm trying to remember all these variables. What do we want to happen? Well, first thing, let's timestamp that sucker, right? So the servo previous Millis is now going to equal whatever current time it is. So we know that this is the time that something is about to happen. And so now what we want to do is that servo position. So we are going to use our little plus, plus equal. We are going to then add to that the servo increment. So you can see here that we started at a position of 0, and we're going to add 0 plus 1 because we're incrementing by 1. So then this value will be 1. The next time around, it'll be 2, 3, 4, as that servo arm does its thing. So there's a problem though, because when we were doing the whole fading with the LED here, we were using bytes. That goes from 0 to 255. Magically perfect for LEDs, but there's no real variable type that goes from 0 to 180. So we're going to have to cap the bottom end and the top end. Because if we keep incrementing, eventually we're going to go 180, 181, 182, and the servo is going to be like, I'm done here, I'm done. So we need to say that when it gets to 180, we'll now increment back the other way, negative increment, if you will, until you get to 0, then positive increment, negative increment. So let's put let's if statement the heck out of it. All right, so here we're going to say if the servo position is greater than 180, right? So if it tries to bypass 180, or the servo position tries to go below 0, not allowed. And I believe I need to stick to parentheses like that. There we go. Over parenthesizing it. All right, so what do we want to happen? So basically, we're going to take that servo increment and we're just going to reverse it. So that's like a quick way of saying, okay, if the servo position tries to exceed 180, well, take that 180 and start minusing the servo increment. So it's going to go back by -1 until it tries to go below 0. So it's going to take that -1 servo increment and negative of the negative, which makes it a positive, and it'll start to positively move. So the last thing we have to do, which we haven't done yet, is to actually write the servo position. Like we've told it a lot of things, issued many orders at it, but now we have to help it carry it out. So we're going to write the servo by the servo position. And I think that should be it. Let's make sure our bracketry is correct. All right. So that's this if statement, that's that if statement, and that's the loop. Okay. Or the function. The loop is down here. So now we have to add our, I believe it was called servo sweep, right? So I think that should be it. Let's try this thing. And I'm gonna tell you that is my that is my demonstration servo. So it's a little, oh, let's see here. Oh, we have some bracketry problems. Oh, right here. It's a semicolon. See, I was sprinkling it everywhere except in all the right places. All right, everybody, give it side eye. Side eye. There we go. That's when it accepts it. It gets all scared. The servo is working mostly. You know, this is my demo servo. It's been pretty abused, so it can look a little jerky, but it's doing its thing. It's like, I want to show you all how Millis works. So I'm going to go over there. Oh, but there's something off. Do you guys see that? Look at that blue LED. It's like blinking. It's not really like fading. So what happened? Something happened that when we added this servo code, it's making the blue wonky. Now, is it something in our code? It totally could be. But I did this because I wanted to remind you of something that I've run into before. Anytime you use the servo library, sometimes it can affect certain PWM pins. And the first one that I find affected is pin number 10. And look, we are using pin number 10. Now, this is different per board. So the first thing to do is try and move that pin to something else. So I'm going to pick another PWM pin because, of course, we want to fade that blue LED. Let's shuttle it to pin number 5. Pin number 5 is a PWM pin, and you really shouldn't be doing this. You always want to like turn off your microcontroller anytime you are changing up connections. It's always good practice. And you'll see me not do it all the time. You know, I try and remind at least you guys, at least somebody should be doing this stuff right? All right, so I've hopped it to pin number 5. I'm just kind of like pushing everything down to make sure, and I'm gonna plug it back in. Now, of course, it's gonna make sense that that blue is not working because we have to change the pin in the code. So let's do that. All right, pin 5. And let's see if this resolves the issue. If not, then we're going to have to start looking more deeply into the code. Yeah. There it goes. So it was that pin. So just remember, anytime you add the servo library or any library that kind of software-wise controls PWM, you may want to like try different pins or read the documentation of how this library works, because it will usually tell you right off the bat, like, hey, you know, there's some conflicts here. So we're not done our testing. We have to make sure that that green lights up. All right, guys, so we have like 4 things going on. No, 4 things going on. Exactly. It's so many things, I can't even count them. So yes, we have our red blinking LED at a rate of half a second. We have our blue LED that's fading up at a rate of 10 microseconds. And then we have our green LED that turns on and off with our toggle because it's constantly reading that every 100 milliseconds. Because think of like if you had like a giant program and your read button is only at the top. Well, while it's carrying out all this stuff, it can't do those 2 things at the same time. Now, is it like textbook doing it at the same time? No, but it's close. Really close, enough to make really awesome functional projects. And then we have our servo, which is like sweeping independently. And this is really cool for robotic arms. We have made Halloween spiders where the legs have to move independently from a sound clip being played, and a motion sensor that senses people coming by, which then activates a servo to shoot silly string at it. So we got all these things working. And you can't do it without Millis. This is your intro to the Millis. But by now, if you were watching this video, I'm going to suspect it's because you kind of reached the limit of what you can do and you want to make your projects that much cooler. So yes, I would love to hear about your projects. Post below, or better yet, I invite you to join our community. We have live lessons. You can watch this lesson live where you can talk to me in real time. Also, say you catch it later or you have a question afterwards. You can always post in the community. I'm always there. We can dissect your projects together. So link for that is below. Also, I always think of more examples or something I should have covered. And I'm like, man, I can't believe I didn't talk about that. So check the tutorial on the website that includes this video. It includes all of this code that we did and even more code as I think of it, because I'm always like updating these things. So guys, I had a blast. I hope to see you in the community or in the comments below. Millis away, people. I want to see some Millisified projects from you. See ya!